Hey there, welcome to YouTube channel TheBitCode। तो लास्ट की वीडियो में हमने डिस्कस किया था एनालिसिस ऑफ द एल्गोरिथम्स एंड द टू मेथड्स टू एनालाइज द एल्गोरिथम। फर्स्ट वाज प्रायोरी एनालिसिस एंड द सेकंड वाज पोस्टीरियरी एनालिसिस। और साथ ही साथ हमने ये भी देखा था कि एल्गोरिथम्स को एनालाइज करने के लिए हम प्रायोरी एनालिसिस का यूज करते हैं। आज की इस वीडियो से हम डिस्कस करेंगे कुछ सिंपल एग्जांपल्स जिसकी हम टाइम कॉम्प्लेक्सिटी कैलकुलेट करेंगे और साथ में हम कुछ लॉग फॉर्मूलाज को भी चेक करेंगे जो एल्गोरिथम्स की टाइम कॉम्प्लेक्सिटीज को कंपेयर करने के लिए हेल्पफुल होते हैं। सो लेट्स स्टार्ट। जब भी हम किसी एल्गोरिथम की टाइम कॉम्प्लेक्सिटी को कैलकुलेट करते हैं, दैट एक्चुअली मींस वी आर डिटरमाइनिंग द ऑर्डर ऑफ मैग्नीट्यूड ऑफ द स्टेटमेंट, व्हिच एक्चुअली मींस कि वो स्टेटमेंट प्रोग्राम एग्जीक्यूशन के टाइम पे कितनी बार एग्जीक्यूट हो रही है, उसी को हम कहते हैं टाइम कॉम्प्लेक्सिटी। नाउ लेट्स हैव ए लुक ऑन लॉग फॉर्मूलाज। जब भी हम किसी दो एल्गोरिथम्स की टाइम कॉम्प्लेक्सिटीज को कंपेयर करते हैं तो लॉग फॉर्मूलाज काफी हेल्पफुल हो जाते हैं। सो द फर्स्ट फॉर्मूला इज log a base a is equal to 1. सेकेंड फॉर्मूला इज log a power b base c. सो हम b को मूव कर सकते हैं, सो इट विल बिकम b log a base c. Similarly, we have the product rule and we have the division rule. In product rule, it will be the sum of log a base c plus log b base c. And in case of division rule, it will be log a base c minus log b base c. Going to fifth formula, we have log a base b is equal to log a base c and log b base c. Sixth formula is a power log b base c. Here we can exchange b and a. So it will become b power log a base c. And the next formula is log a base b is equal to 1 upon log b base a. So आगे आने वाले एग्जांपल्स में हम इन फॉर्मूलाज की हेल्प लेंगे टाइम कॉम्प्लेक्सिटीज को कंपेयर करने के लिए कि कौन सी टाइम कॉम्प्लेक्सिटी ग्रेटर है, विच इज ग्रेटर। Now let's start with the examples. So our first example is very simple. So यहाँ पे हमारा प्रोग्राम दिया हुआ है, इसके अंदर सिर्फ एक ही स्टेटमेंट है, दिस इज फर्स्ट स्टेटमेंट एंड वी हैव टू कैलकुलेट द टाइम कॉम्प्लेक्सिटी ऑफ दिस स्टेटमेंट। सो जैसा कि हमने स्टार्टिंग में देखा था कि जब भी हम टाइम कॉम्प्लेक्सिटी को कैलकुलेट करते हैं हम देखते हैं कि वो स्टेटमेंट कितनी बार एग्जीक्यूट हो रही है प्रोग्राम एग्जीक्यूशन के टाइम पे। सो ड्यूरिंग द एग्जीक्यूशन ऑफ दिस प्रोग्राम this statement will be executed only once. So the time complexity of this program is big O of 1. This statement will be executed only once. So time complexity of this program is constant. This program is taking constant time. For the time being, you can ignore this big O notation. We will discuss in the upcoming videos about these notations like big O, theta, omega. So we will be discussing about all these notations in the upcoming videos. So let's go to next example. So what is actually happening in this program? So in this while loop is used and in condition we have provided 1 which is always true. And we have to find out the time complexity of this program. So ये कंडीशन हमेशा ट्रू रहेगी। सो दिस इज एन इनफाइनाइट लूप। दिस प्रोग्राम विल कीप ऑन रनिंग, बट हमने एल्गोरिथम की डेफिनेशन के टाइम पे ये देखा था कि द एग्जीक्यूशन कंप्लीट्स आफ्टर ए डेफिनेट इंटरवल ऑफ टाइम, बट यहाँ पे ये प्रोग्राम इंडेफिनेट लूप में रन कर रहा है। सो दिस इज एक्चुअली नॉट ए एल्गोरिथम. So the time complexity of this program is undefined. We cannot calculate the time complexity of such programs. So now let's go to next example where we will check how the execution happens in a for loop. So in this example we have to find out the time complexity of this program. So our first statement is printing high and this is our second statement. Our second statement is inside the for loop. So before calculating the time complexity, we have to understand how exactly each part of the for loop is executing. What is the execution flow of this for loop? So we will be calculating the time complexity of this part. Let's say this part A, and we have to find out the number of executions of this part. Let's call it as B, and we have to find out the number of executions for this part. Let's call this as C, and the number of executions of this statement, let's call this statement as D statement. So before calculating the number of executions of each of these parts, let's check the flow of execution of this program. So first this statement will be executed, then the initialization part will be executed, which is A, then the comparison part will be executed to check if the condition is true, then our statement will be executed, and after the statement our increment operation will be executed, and then again the comparison. So this is the execution flow of our for loop. So अब हम चेक करते हैं कि हर एक पार्ट कितनी बार एग्जीक्यूट हो रहा है. Let's start with A. So A is initialization part. So this part is initialized only once in the beginning of the for loop. So this will execute only one time, executing only once. So now let's see the number of executions of part B. So for I is equal to 1, the comparison will be done. For 2 it will run, for 3 it will run, and so on. It will run for n, then it will run for n plus 1. But for n plus 1 it will fail, but it will run. So the number of times the B part is executing is n plus 1 times. How many times the C part is executing, which is increment operation. So I will be incremented after 1. For 1 this increment is not executing. For 2 it will run, for 3 it will run, and it will keep on running until n plus 1. For n plus 1 also it will run. So the number of times the C part is executing is n times, because it is not running for 1. Now let's see the number of executions for our statement D. So how many times we are coming inside this for loop? It will depend upon this condition. So the condition is true for 1, 2, 3 and for n. For n plus 1 the condition is not true. So this statement will not be executed. So D statement is running for n times. And our first statement is running only once. So what is the time complexity of this program? So the time complexity of this program is time complexity of statement 1, which is big O of 1, time complexity of statement 2, which is big O of n, and the total time complexity is big O of n plus 1, which is nothing but big O of n, because we are only taking the dominating and the largest parts. One is constant, so we can ignore this constant in our priori analysis. So let's see one more example and try to understand this part. So we have a program P1. Program P1 does not have any loops. So program P1 is taking only 1 second to finish its execution. And we have another program P2. So let's consider that this program is having 100 loops, just for the example. And this program P2 is taking 24 hours to complete its execution. So by comparing both of these programs, which part is more valuable? So we can say that wherever CPU spends more time, is the more valuable part of that program. Which are mainly loops. Second point that we can say is, so from this example we can say that time complexity calculation is nothing but finding the loops only. Time complexity of any program P is nothing but finding loops only, which is the largest part or the largest loops. So that's it for this video. In the next video, we will be covering the examples related to the for loop and then the independent nested for loops and the dependent nested for loops and also the gate questions. अगर आपको किसी भी पार्ट के रिगार्डिंग कोई भी प्रॉब्लम आती है तो आप कमेंट बॉक्स में लिखकर हमें भेज सकते हैं. सो स्टे ट्यून्ड, सी यू इन द नेक्स्ट वीडियो, बाय बाय.